Welcome to lecture 16 of Financial Econometrics, and we are continuing our discussion on dummy variables. So this is part 2 of the dummy variable lectures. Moving towards the contents, previously we saw what if we had one categorical variable, although there were different categories in it. Previously we saw one categorical variable, independent variable, and understood what the interpretations would be, both in case if we had two categories or more than two categories. In this case, we are going to discuss what if we have two qualitative variables, two categorical variables. So how would we interpret in that case? Then we would see what if we had a categorical and continuous variable, both of these types of variables in our data. So our one independent variable is categorical and the other independent variable is continuous. And then we are going to explore the concept of interaction term. And that would mark the end of our discussion on dummy variables. So starting with the concept of two qualitative variables. For example, we want to study the effect of marital status, whether a person is married or single, and gender on the wages, and the wages variable is in dollars. So now you would have seen that this is our wage variable, which is in dollars. It obviously is continuous, but that is not the aspect of our lecture. We aren't going to discuss on this aspect. What we are going to discuss is that both these variables are qualitative variables. They are categorical variables. They both are independent variables, and when we have these two different categorical variables, no matter how many categories do we have within those variables, how would we interpret this? So in this case, we have a marital status, which we call D2. We will call this marital status variable as D2. And it would have a value of 1 if an individual is married and 0 otherwise, obviously when the individual is single. Then we have gender variable, which we would call D3. Remember, whenever we form dummy, we follow the convention of naming it as D variable, but that is not necessary. You can name it as you feel convenient. So we would give it the value of 1 if the individual is female and 0 if the individual is male. Okay, so after running the regression of these two independent variables on the wage variable, we would get this output. So how would we interpret this? Remember, in case of one categorical variable, we would say that the omitted category, the value of omitted category was in the constant term. But in this case, we have two categorical variables and we have two omitted categories. For example, in case of D2, the omitted category is being single. In case of gender, the omitted category is the male category. So what would this represent? Would it represent the single category, or would it represent the male category? Now, in case when we have more than one categorical variable, you have to be careful in interpreting this term, this base term. So in case of more than one categorical variable, all the omitted categories would be represented by the constant term. So in this case, this 8.1 would mean that, let's say these are hourly wages, per hour wages. So we can say that a single, it is the omitted category, male would have an hourly wage of $8.8. So these are hourly wage, per hour wage. This D2 is for the married variable or category. So we can say that an individual who is married would earn $1.09 higher than the non-married individual. So if I put it this way, that what is the expected value of y? Y is our wage variable. Given that D2 is 0, that means the person is not married, single, and D3 is 0, that is the person is not female, he is a male, his expected wage would be B1. This is what we have already discussed. What is the expected value or expected wage when a person is married? That means D2 have a value of 1 and it would have a value of 1 when the person would be married. And D3 is 0. And D3 is 0 means that the person is male. So in that case, his expected wage would be B1 plus B2. That would be 8.81 plus 1.09. So what this means is that married person would earn 1.09 higher than the single, whether male or female. So in this case, we are just finding out the expected value of or expected wages in case of a married male. So that would be B1 plus B2. What this coefficient would represent, this differential coefficient would represent, because it is a minus sign, then we would say, and it is for gender variable and female would have one value, so we would interpret it as that female would earn $1.67 lesser than male. Whether they are married or unmarried, they would, this is the gender variable, so they would earn it is unfortunate, but anyhow, it is they would earn $1.67 lesser than male. So if we wanted to find the expected, we found the expected value of a single male, then we found the expected wage for the married male. What if we wanted to find the expected value of a single female, wage of a single female? Then that would be expected value of y, given that D2 is 0, that means the person is single, and D3 is 1, that is the person is female. So in that case, the expected salary of that individual would be B1, which is constant 8.81 plus the B3. So it would be minus, but it would be as 8.81 plus minus 1.67. So that means the female would earn $1.67 lesser than male. What would be the expected value in case the person is married and female? So that would be B1 plus B2 plus B3. Remember, B3 would be minus in bracket, or we can directly deduct it. But in this way, it is easy to understand. So this would be the expected value of expected wage of the married female. So what we wanted to understand is, the main idea is that the base category would have the value of the both the omitted categories. So if we had 3 categorical variables, so all the omitted values would be in the base category. Moving on to our next case, where we have an independent categorical and independent continuous variable. How would we interpret? So in this case, we are again taking the example that we had discussed in our previous video, which was the salary of a public school teacher if they belong to different cities. Say we took the example of Karachi, Lahore and Islamabad. So we compared the wages, the expected wages. We are adding, that was obviously categorical variable, the city is variable, the location variable was categorical. We are adding to it another variable which is continuous, and that variable is government education spending. So obviously this spending would be in continuous form. This would be a continuous variable. So if we ran the analysis, this obviously would be the omitted category. In previous case, the omitted category was Karachi, so this would be the public school teacher in Karachi. Then this would be for Lahore and this would be for Islamabad. But we have already discussed it. We are not going to further repeat ourselves. The only thing that we are going to understand is this continuous variable. So the continuous variable is again easy to interpret. It is as with our previous OLS regressions, we have interpreted this. The interpretation would be that on average, a public school teacher's salary would increase by 2.34 dollars for every $1 of spending by the government. Or let me repeat it in a simple way. For every $1 increase in spending by government on education, the salary, no matter in what city the teacher is, their salary would increase by $2.34 or rupees. This is how we would interpret it. So we move on towards our interaction variable, but before that, let me revisit your idea of moderating variable. Let's revise that concept. Remember from your research methodology coursework, you would have studied 4 different kinds of variables. We had independent variable, we had dependent variable, we had moderating variable, and we had mediating variable. So what was moderating variable? A moderating variable was a variable that modifies the relationship between independent and the dependent variable. It can either change the direction or strengthen the relationship. So for example, if we take the example from the book of Sakran, the research methodology book of Sakran, you can find this example in any edition, and if you want to further explore it, I would recommend that you move towards that reference book. So the example is that workforce diversity have a positive impact on organizational effectiveness. So workforce diversity increase, the organization effectiveness would increase. There is a positive relationship. But there is another variable which is managerial expertise, whether the manager is have the expertise to exploit or utilize that workforce diversity. If manager didn't have the expertise, then that workforce diversity would have a negative impact on the organization effectiveness. And if the manager had the expertise, then that workforce diversity would have the positive impact. Now you would see that there is this variable manager expertise which is changing the direction. It is converting the positive direction to a negative direction or vice versa of the relationship between the independent and the dependent variable. It isn't affecting the variable directly, but it is affecting the relationship between those variables. And in this example, this particular example, there was a change in direction. It is not necessarily that this moderating variable would always change the direction. It can also strengthen or decrease the strength of the relationship. For example, if we have this kind of a fitted line, and if we introduce a moderating variable, it can decrease the slope of the relationship. So the relationship is still there, it is still positive relationship, but the strength of the relationship had decreased. This is when the relationship strength would be affected. And when the direction would be affected, that would mean if there is a positive relationship, that would be converted into a negative relationship or the other way around. But the idea is that the moderating variable would either change the direction or the strength, change the strength of the variable, the relationship. Okay, so why do we need to understand this moderating variable? Remember, in case of interaction term, This is when we have a moderating variable, we would use this concept of interaction term. That is when specifically this moderating variable is a dummy variable. We can use for continuous variable, but in this lecture we are going to understand for the case of dummy variable. So for example, again the example of salary. So as education increased, the wage or salary would also increase. This is the positive relationship. And if I draw it on the graph, this is how the graph will look like. But there is again a variable, gender variable, and we have seen multiple times that female earns lesser wages than male. So even if for the same level of education, this is education, this is our independent variable, and this is salary or wage. So there is a positive relationship. As the education increases, the salary increases. But the increase in salary for the same level of education is lower for female as compared to male. So in this case, this gender variable is, which is a categorical dummy variable, is playing a role of moderating the relationship. It is not changing the direction. Obviously, in this particular theoretical example, an increase in education of one gender would not decrease their salary. So if female education increases, their salary would not decrease. That is not the case. But what would happen is that the slope would be comparatively lesser. So for example, this is the slope for the male case, this is the slope for the female case. So for the same level of change in education, so if the education changed from this level to this, it increases to this level, male salary would increase by higher amount as compared to the female salary, because the slope is lesser. This is the slope of the male salary, and this is the slope of the female salary. So this is where we are going to use the interaction variable. Now let's see how we can use this interaction variable. So we have this gender, we have coded it. Male would have a value of 1. Remember, in previous slides I have used 1 for a female, and that is just to make you understand that it doesn't matter what value you give to which category, you would have to interpret it in with respect to that coding. So a male would have a value of 1 and female would have value of 0. We have education, so this specific individual who is male would have an education of 10. This is specific individual who is female would have an education of 16, and so on and so forth. So now we are going to use create another variable, which is the interaction term. We call it the interaction term. And this is simply the multiplication of these two variables. So remember, the education variable was the independent variable, the wage was the dependent variable, and we said that there is the moderating effect of gender. So we are multiplying these two variables. So let's create another model where we have x1, x2, we have two independent variable and we have one dependent variable, and there is a moderating variable which just affect this x1 variable, not the x2 variable. So in this case, what would we do? We would have this x1 variable, this m variable, which let's say is moderating, a categorical variable. We would multiply this x1 variable with m, and we would have x1m. So we have used this similar concept here. We have multiplied this dummy with education, and we would have a value of 0 for females here. That would automatically happen, because 0 multiplied by any digit would have a value of 0. So now we have these series. What we are going to do is we are going to regress wage on education, gender, and then this interaction term. So this is how we would perform the moderation. Okay, so let's take that example of dependent variable salary. B1 is the constant term, then we have the dummy for gender, where we have given value of 1 to male, we have education, and then we have beta for, which is the interaction term. It is dummy multiplied by these two variables are multiplied. So what is the expected value of male? The expected value of male would be B1 plus B2. This would, because this would have a value of 1, so 1 multiplied by B2 would be equal to B2. Then we have this B3, and 1 multiplied by education would give us the value of B for education. If we simplify this, we have two education terms, so we can take the common, and then we have beta 1, beta 2, and then beta 3 plus beta 4 education. And we would come back to this in a while when we see the expected value of female. So salary of a female, because in this case, in case of female, this DM would have a value of 0, so 0 multiplied by any value would have end result of 0, so we do not need to write beta 2, it would obviously be 0 value. B3, we have written it. Again, this DM would have a value of 0 in case of a female, so 0 multiplied by any value of education or any other digit would again be 0. So what we get is that the expected value of a female would be beta 1 plus the beta 3. But in case of male, the expected salary would be beta 1 plus beta 2, which is the premium that, beta 2 is the premium that this person is getting for being male. And then you can see, this is the part that we are more interested in this slide. This B4, which is the interaction term, shows us that for the same level of education, a female would have an increase in salary of B3. So if education increases, the female salary would increase by B3, but in case of a male, if education increases, the salary would increase by B3 plus B4. So there would be a higher increase in the salary. So this B4 is the interaction term. So this B4, if it is positive, it is a positive value, it is greater than 0, it turns out to be greater than 0. So in this specific scenario, the interpretation would be that additional effect of one more year of education would have a greater impact on the salary of a male rather than a female. So if it is greater than 0, B4 is greater than 0. So let's put number into this equation and it would give us a better idea. Again, we have the same equation, we haven't changed it. We are putting the estimated value. So let's say we took the wages of different individuals, both male, female. We had a sample. We ran the regression. We took their education level. So now, how do we interpret the if a person is a female, dummy is 0. Remember, this intercept. The interpretation is that when all the independent variables are 0. So if the person do not have any education, it's a female, the base salary, the salary would be 10,000 rupees. For a male would have a 500 rupees, 500 rupees higher than female. For every 1 year of education increase, the salary would increase by 100. And in males, for every 1 year of education, the male salary would increase more by 50 rupees higher than as compared to female. So again, if we plot the values in previous in the equation that we designed in the previous slide, this is how it would look like. And if we compare it with the case of female, so now you can see that for the same level of education, a female would earn this much and a male would earn this much. This 500 rupees is a premium for being male or that specific category. And this 50 rupees, remember, if education increased by 1 year, in this case, let's say for first we discuss in this case, if the education increased by 1 year, the salary of a female would increase by 100 rupees. But in case of a male, if education increased by 1 year, its salary would increase by this term, that is 150. 50 rupees higher than the salary of a female. So if we graphically represent this, then this is the base salary of female, base salary of male, 500 higher than demi-variable dm in previous slide. So the slope is higher for the male. This is because of the B4 as compared to the slope of female. So that is the end of our discussion on the demi-variables.